would like to first common rules that we use when we're solving the integral. Oops. Okay. So the first thing I want to mention will be the integral by substitution. Right. So integral by substitution. So if we cannot see the answer for the integral by inspection, then the method of substitution is deployed. So I'll share an example. So for example like this, we want to find the integral of 2x minus 1 to the exponent of 5, which if we do not know the substitution rule, it will be extremely hard for us to do it. So whenever we see questions like this, like a function with a really high exponent, we always use the substitution rule. So we let u is equal to 2x. So the 2x will be substituted by u. And then we're solving the du dx, which we just take the derivative of u. And this will give us give us a 2. And the du will be equal to 2 dx. In other words, if we move the 2 to the other side, then dx will be 1 over 2 du. Right. So now we replaced 2x minus 1 by u and write dx in terms of du. I'll just write this down. Replace 2x minus 1 by u and write dx in terms of du. So now our question actually switched to, I'll just copy the original one first. This becomes to u to the exponent of 5 du over 2, which we can rearrange this as integral of 1 over 2 u to the exponent of 5 du. And so we just solve this integral, which is 1 over 12 u to the exponent of 6 plus c, which is a constant. And our final step will be we need to substitute the u back. So remember, we let u is equal to 2x minus 1. So after we solving for the very last step for u, we need to substitute the x back, which will be 1 over 12 2x minus 1 to the exponent of c plus c. Right. Yeah. So after introducing the integration by substitution, and I would also like to share the rule of solving integral 1 over n. And this is always equal to ln absolute value of n plus c. Always remember to take the absolute value and do not forget the c, which is a constant. Right, so now let's move to this question. So the integral second x dx. So since we want to apply the substitution rule of it, we need to times a function that is secant x plus tangent x secant x plus tangent x. And why we can do this is because since the numerator and the denominator are exactly the same thing, so we pretty much just times the original integral by 1, which is can remain its original value. Yeah. So coming up, we move the secant x to the numerator part, which will give us secant x tan x. Since we have secant x times secant x, so we got secant x squared. The denominator remains the same, so we have secant x plus tangent x. And now let's use the substitution rule. So let u is equal to tan x plus secant x. And remember what we did previously, we need to take the derivative of u, which is du dx is equal to secant x tangent x plus secant x squared. Oops. dx dx. Right. So now we have dx will be 1 over secant x tangent x plus secant x squared. So we substituting this back will give us integral 1 over u du. And remember, whenever we take the integral of 1 over something, it's gonna always going to be here, ln absolute value of n plus c. So in this case, it will be ln absolute value of u plus c. Remember our last step will be we need to substitute the x back, and we have u is equal to tangent x plus secant x, so we just put it back there, tangent x plus secant x plus c. Right. So yeah, so our answer will be ln to the absolute value of tangent x plus secant x plus c. And let's see. Yeah, so for question here, so for the answer part here, if you forget to put the absolute value sign, all the other steps are correct. So we'll just leave a comment. Good work. And missing absolute sum. Right. So moving on, the second question, we need to find out the rules in geometric translation. whenever we talk about the translation, it is a function that moves an object a certain distance, and the object may not be rotated, reflected, or resized, and every single point of the object must be moved in the same direction with the same distance. This is very important. So every point in the object must be, the first one will be moved in the same direction. Second one with the same distance. Right. So let's say I'll draw a graph here. We building a rectangle, and for here's a coordinate, let's say 1 0, and this part will be 3 0, and let's do 3 1 and 1 1 as our 4 coordinates for the rectangle. Now let's say if I want to move it up 1 unit, that means we need to add this certain units to the y coordinate for each of the coordinate. So let's say I want to move up 1 unit. Then our new graph will looks like this. Change to another color. So for 1 1, it will transfer to 1 0. Its original 1 0 will be transferred to 1 1, and the original 3 0 will transfer to 3 1. And for 3 1, since we move up 1 point, it will become to 3 2. And for 1 1, it will become to 1 2. So as you can see from this example, if we want to move, let's say, k units, we need to add k, like the k value, to the y coordinate. So let's do another example. If we have a square, let's do 0 0, 1 0, 1 1, 0 1. If we want to move this to the right for 1 unit, right 1 unit, let's see what we got. So the 0 0 will transfer, the 0 0 will transfer to 1 0, and 0 1 will be transferred to 1 1, and 1 1 will be transferred to 2 1, and 1 0 will be transferred to 2 0. Right. So I'll list all the coordinates on the side, just for easy for observing. So the original coordinate for the square is 0 1 0 0 1 1 1 0, and since we move it to the right for 1 point, we will have 1 1. 1 0, 2 1, and 2 0. So we can see here, if we want to move the square to the right for a certain unit, we need to add a certain value to the x coordinate only. Oops, that's a typo. There should be 2 0. As you can see, the y coordinates remain the same. The only thing changed will be the x value. So now let's do a little summary. So if we want to move up, let's say k points, we need to add k to the x coordinate. Since this is where we're only moving up and down, and so the original xy becomes to x plus k y. Remember, the only thing that is changed, oops, that's a typo, will be x y plus k. Yeah. So we maintain the x coordinate the same because it's only up and down, and the only thing changed will be the y coordinate. And if it's want to move it down k points, we just need to subtract b to the y coordinate. So that becomes to xy y minus k. Yeah. So just saying similar to move k points, we just do this backwards, and it will become to move k downwards. And for left and right, if it's right, if we want to move it right a points, we just need to add a to the x coordinate, which xy will become to x plus a y. Because we are only moving to the right or to the left, the y coordinate always remains the same. And same for the left a point. We subtract a from the x coordinate. So xy will becomes to x minus a y. Oh, there was a typo. For we want to move up k points, is only dealing with the k coordinates. Yep. So by knowing all this, let's do a example just for us to better understanding what these are, what algebraic representation of translations are. So let's see, xy would becomes to x plus 3 y minus 2 as our translation. And we got 3 points. So A will be 1 0, B will be 0 0, C will be 5, 1. Yeah. So after translation, the new A, as you can see in the translation part, so the X part only dealing with the X coordinate, and the Y part only dealing with the Y coordinate. So 1 plus 3 will be 4, and 0 minus 2 will be negative 2. Same for B. 0 plus 3 will be 3. 0 minus 2 will be negative 2. And for C, 5 plus 3 will be 8. And Y minus 2 will be negative 1. So those are the coordinate after the translation. So let's see. Yep. Answer is correct.